Okay, morning guys. So today I'm going to introduce the required practical for chemistry or for combined science trilogy, and it is the electrolysis of aqueous solutions. Now there are three solutions that we have to look at generally. We have to look at sodium chloride or table salt solution, so dissolved in water, copper chloride solution, which is copper chloride dissolved in water, and copper sulfate solution, which is this, and it's copper sulfate crystals dissolved in water. Now, there's usually a question as to why don't these substances conduct as a solid. So I'm just going to show you that in the first instance, the sodium chloride, the copper chloride and the copper sulfate do not conduct as solids. Now to do this, we've built a little circuit. If I connect these two leads together, you can see that the light lights up. So when there is a conductor between these two, it works. When there isn't a conductor, it doesn't. So if I were to get my set of keys out, I can put it on the keys. You can see there that the key conducts. Without it, it doesn't conduct. So what I'm going to do is I'm going to put the electrodes into each of the solids as we start. So into sodium chloride, put the electrodes in, it does not conduct. I'm going to put the same electrodes into copper chloride, and you can see that it does not conduct. And then finally, I'm going to put the same electrodes into copper sulfate, and you can see that it doesn't conduct. Now, just to be able to convince you that things are slightly different, what I'm now going to do is, apart from these big crystals we've grown, I'm going to add a little bit of water to each of the substances you have seen so far. I'm just going to cheat with that one and use copper sulfate straight out of the bottle, already dissolved in water. I'm going to add some water, and in proper Blue Peter, I haven't got any, so I've got to go and get a flask or a beaker. Cold water straight from the tap. I'm going to put my electrodes in. And I've got to be a little bit careful here with one hand. I don't want them to touch. I'm going to put them in. You can see it doesn't light. I'm going to add water slowly to start dissolving the salt. And you can see that as the salt begins to dissolve, it conducts electricity and it lights. Take it out again, it doesn't light. So that is how I made the sodium chloride solution that you will see me electrolyse in a few minutes. Second one, copper chloride. Again, put my electrodes in. You can see it doesn't conduct. Start to add water. You can see that it does begin to conduct. Now you should be discussing amongst yourselves or with your teacher as to why the solutions conduct but why the solids do not conduct. And then finally, just to show you the copper sulfate straight from the bottle, because I didn't want to spoil those beautiful crystals, we'll put in, and you can see the copper sulfate conducts. Okay, now to answer my question of you earlier, why do they conduct? It's because the ions that are in the solutions are now free to move. When they were as solids, the ions or the particles could not move. Now what I'm going to do is I'm going to show you now, set up the electrolysis cells that we will use for the experiment. So I'm going to add a little bit more water to this one. So my second solution will be copper chloride. Okay, I'm going to add a little bit more water just to make sure I've cleaned out all of the powder that we're using. So the second solution is copper chloride. The third solution that we'll be using is copper sulfate. So I'm going to add the copper sulfate to my electrolysis cell, and in the same way that we set up the sodium chloride one earlier, I'm going to run these two as well, and we'll look at the results for all three. So it's sodium chloride, copper sulfate. And you should be predicting with your teacher what the products are at the electrodes. For all three experiments, I've put the anode or the positive on the left as you look at it, and I've put the cathode or the negative on the right as you look at it. Thank you.